So here I will be covering coordinate geometry, and I'm just going to focus on straight lines and points. Those are the most important for the GRE. So the first is the concept of XY plane. Just refers to the plane, the two-dimensional plane, for example, where I'm drawing. And you have the coordinate system. You have the x-axis, y-axis. Origin we call 0, 0. And then if you see a point like 4, 3, 4 refers to this distance from the y-axis. So that's 4. And 3 is this vertical distance. Or you can think of 4 along the x-axis, 3 along the y-axis. And this quadrant, it's called quadrant 1. You technically don't need to know the nomenclature. They will write it out, but it's known as the first quadrant where both x and y coordinates are positive. In the second quadrant, x is negative, y is positive. Here, they're both negative. And here, x is positive, and y is negative. So just the notation as far as the XY plane is concerned. Now, the first concept has to do with finding the midpoint. So this is finding the midpoint if you're given 2 points. And let's say the 2 points are 2, 3, and 8, 11. So to find the midpoint, so first I'll just give you the expression, is you take the midpoint of the x coordinate. So that would be the midpoint of the x coordinate, would be the x coordinate of the midpoint, and the y coordinate of the midpoint would be just the average of the two y coordinates. So 3 plus 11 over 2. So this would be 10 over 2 is 5, and then 14 over 2 is 7. So the midpoint here is 5, 7. So in general, it's just the average. And the other important idea is to be able to find the distance between 2 points. And the easiest way to do this is to overcreate a right triangle. And whichever line segment you need to find the distance, you make that as the hypotenuse. So here I've drawn these two lines. This is parallel to the y-axis, and the other line is parallel to the x-axis. So the coordinates here, this has the same x-coordinate as that point there, so 8, and then the y-coordinate is 3. This distance here is 6, the difference between 8 and 2. That distance is difference between the y-coordinates. 11 minus 3 is 8. Again, not drawn to scale. So now I have the two sides, and I can apply the Pythagorean theorem. D squared is equal to 6 squared plus 8 squared. Here I've chosen some nice numbers. So that's equal to 100, which means D is 10. So you can apply this approach to any of these, any 2 points are on the plane. And it doesn't matter what the orientation is. So just to summarize what these look like is if you're given these points x1, y1, and this is x2, y2, and I call this xm, ym as the midpoint, and the coordinates of the midpoint are just the average of the x-coordinates of the 2 point, and same thing for the y-coordinates of the midpoint would be y1 plus y2 over 2. The distance formula, you don't have to memorize this. As I said, you can just create this right triangle. This distance is x2 minus x1. That distance is y2 minus y1. And if we call that distance d, our relationship is, we're really applying the Pythagorean theorem. And d is then the square root. So that's called the distance formula. Now, the next important concept is that of slope when it comes to lines and line segments. So if we look at, so let's say we have this point 3, 2, and say 9, 5. I connect these two. And so if we have to find the slope of this line segment, what we refer to that is how much, it's really the ratio of the side that's upright to the base. So it's you can also think of it as rise over run, meaning how much do we go up when we go a certain distance in the horizontal direction. So now this distance is 9 minus 3 or 6, and that is 5 minus 2 or 3. So here really the slope is 3 over 6 or half. So the slope in general is just the difference between the y coordinates over the difference in the x coordinate. So here the slope is half, and you also see the concept of the equation of the line. So the concept of the equation of a line, really what it means is that if you're given any 2 points, how do we find all these other points that fall on that line? So really what an equation of a line defines is that, let's say you're given y equal to 3x plus 2. So when we draw this, maybe it looks something like that. What it's describing to you, the x and y, are the set of all points that fall on that line. So if, for example, I said, well, if x is 3, what is y? So you replace x equal to 3 here, and you will get 11, which means this point, 3, 11, is on the line. It falls on the line. So really the equation of a line is describing the entire set of points that fall on the line. And there's an infinite number of points that fall on the line. Now, one way to test if a point falls on the line or not is the whatever coordinates I give you. So, for example, if I say 1, 6, and I says, does the point 1, 6 fall on the line? Then all you do is you replace x with 1 and you compute y. And you say, does that come out to be 6? In this case, it comes out 5. So we say no, because 1, 5 is on the line, but 1, 6 is not on the line. So that's sort of what really they mean by the equation of a line. So let's look at it in a general way. So if you're given, I'll kind of develop the equation of a line concept, and then we'll do a specific example. So let's say the 2 points are x1, y1, x2, y2. And let's say a point xy falls on the line. And really, I need to be able to find out all the points. Right? So you're given these 2 points. So I know that the slope is just the difference between the y coordinates and the x coordinates. And I'm just going to call that m. Okay? And I know that if this point falls on the line, then when I connect that point to any of the points, it could be either to that one or this one, I'm going to just choose that, then the slope of that line segment has to be the same. Because if a point falls, when you connect any 2 points on the line, the slope has to be the same. So this has to equal y minus y1 over x minus x1. Otherwise, this point would not fall on the line. And I'm going to call this m. This is m. So now I have this equation. I'm going to rewrite this, multiply both sides by x minus x1, and then expand this. And then I'm going to add y1 to both sides. It becomes mx minus mx1 plus y1. And now this is some number, because ultimately these are numbers, the points, slope, right? So I can consolidate it to this variable b. So this is called the slope-intercept form of a line, right? And so this is called the slope-intercept form, and I'll explain to you where this terminology is. So m, we noticed earlier, we called this was the slope. So m is the slope. Now the question is, what is b? And the way you can visualize this is that if I draw this line, and I say, okay, where does this line intersect the y-axis? So we know any line that intersects the y-axis, the condition is that the x-coordinate is 0, because it's these points, all of them, x-coordinate is 0. So this point would be when x is 0. So you would find that y is 0, y is b, which means that this coordinate is 0, b. And this is called the y-intercept. And it shows up here. So when you see an equation of a line y equal to 2x plus 3, you say right away slope is 2, and the y-intercept is 3. Then we say, how do we find the x-intercept? Well, the x-intercept condition is when y is 0. So all these lines that intersect here, the y-coordinate is 0, all these points. This could be 3, 0, this could be 1, 0, but the y-coordinate is 0. And to find that, you set y to 0. So that would give us 2x plus 3 equal to 0. If you compute this, x is minus 3 over 2. So this point would be minus 3, 2, 0. And if we want to do it in a more general way, in the y equal to mx plus b form, you set y to be 0, and you isolate x, becomes minus b over m. So this is the x-intercept, where b refers to the y-intercept of the line and m is the slope. So you can also use that relationship, or you can always do what I did earlier, is to set them equal to 0. Okay, so let's look at a general case, because this would probably be the most common scenario. You're given these 2 points, 3, 2, 9, 5, and you're asked to find everything about the equation of a line, or line that passes through these 2 points. So you start with slope, and that would be the difference in the y-coordinates, 5 minus 2, 9 minus 3, 3 over 6, which is half. So we have our slope. And you start with the general equation, y equal to mx plus b, and we know m is half. Now I need to find b. So we know that the line passes through that point, so it has to satisfy this condition. What that means is when x is 3, y must be 2. So you make x 3, and we still don't know what b is, then y has to be 2. So we can use this to compute b. 2 minus 3 over 2, so this is 3 over 2, that becomes half. So that y-intercept there is just half. And now we have the complete equation of a line. And we can also find the x-intercept. What you have to do is to set y to 0, and you compute what x is. So that would be half x plus half equal to 0, half x equal to minus half, and you'll find x is equal to minus 1. So here, if you were to extend this, the x-intercept would be somewhere here, minus 1, 0. Y-intercept is 0, half, or y-intercept is half. So that summarizes the concepts related to equation of line.